Hi, my name is Glorba and this is my projectile project. The height of the court is 3.05 meters. The distance from me to the court is 4.6 meters. My height, when you convert it into meters, is 1.6 meters. My height from the court is 1.43 meters. To make a perfect shot for my height, you need a 45 degrees angle. And whatever comes up must come down. The force of gravity is negative 9.81 meters per second squared. Now let's move on to the x and y position. X of force equals the unknown velocity of x times time plus the x initial. The y equals the y of force equals the 1 over 2 acceleration times time to the second power plus the unknown velocity of y times time plus the y initial. When solving this equation, we're going to be using SOHCAHTOA. In this case, x will equal cosine of 45 equals the velocity of x over the unknown velocity, which equals this. Then we're going to be using adjacent over the hypotenuse. So in comparison, when solving for y, we would use sine 45 degrees equals the velocity of y over the unknown velocity, which equals this. Now we're going to be solving for the x position. Remember, this is how the x position looks. We're going to be bringing down 4.6 meters because that is the distance between me and the court, which equals parentheses the unknown velocity cosine of 45 degrees close parentheses times time plus 0. The reason 0 is because that is our starting point. We're going to bring it down and it's going to look like this. 4.6 meters equals parentheses the unknown velocity cosine of 45 degrees close parentheses times time. Now we're going to be solving for the y position. Remember, this is how the y position looks. We're going to be grabbing 3.05, which that is the height of the court, which equals to 1 over 2 parentheses the acceleration of gravity negative 9.81 close parentheses times time to the power of 2 plus parentheses the unknown velocity sine of 45 degrees close parentheses times time plus 2. Now we're going to solve for the y position. Negative 1 over 2 parentheses 9.81 close parentheses times time to the second power plus parentheses to the unknown velocity of sine of 45 degrees close parentheses times time, which equals 1.43. Now we're going to be solving for the unknown time. We're going to be bringing down 4.6 equals parentheses the unknown velocity of cosine of 45 degrees close parentheses times time. We want to isolate the t, so we're going to be dividing, and it's going to look like this. T equals 4.6 over the unknown velocity of cosine of 45 degrees. Now we're going to be converting this equation into a y position form, which will look like this, then equal to this. Negative 1 over 2 gravity, parentheses 21.16, why 21.16? Because 4.6 times 4.6 equals 21.16 since it's to the power of 2 over velocity to the second power cosine to the second power close parentheses 45 degrees plus parentheses 4.6 the unknown velocity of sin 45 degrees over the unknown velocity cosine of 45 degrees close parentheses, which equal 1.43. To find tan, we have to cross out the unknown velocity, which we will have sine of 45 degrees over cosine of 45 degrees, which will equal tan of 45 degrees. Now we're going to be using the 1 over 2 from the y position and converting that into the equation, multiplying it, which we get parentheses negative 10.58 gravity over the velocity to the power of 2 cosine to the power of 2 over 45 degrees, close parentheses, plus 4.6 tan of 45 degrees, which will equal 1.43. So we're wanting just to have the velocity on this side. So how we do that is we move over negative 10.58 times gravity to this side, which we divide. Then we bring it down and square root both sides, which we get the velocity by itself, which equals negative 10.58 times gravity over parentheses 1.43 minus 4.6 tan of 45 degrees, close parentheses, cosine to the power of 2 of 45 degrees. Now that we got the equation, we are now going to insert the Earth's gravity, which will look like this. The velocity equals square root negative 10.58 parentheses 9.81 parentheses over parentheses 1.43 minus 4.6 tan of 45 degrees parentheses cosine to the second power of 45 degrees, which will equal the initial speed and velocity of 8.09 meter per second. With this math, we know that the basketball player needs to throw the ball with the initial speed of 8.09 meter per second. The mass of a girl's basketball is equal to 22 ounces, which equals to 0.62 kilograms. We need to find the force. So what we're going to do is we're going to multiply the mass and the acceleration due to gravity, which is the initial speed we need to make a 45 degrees angle shot, which will equal 5.01 newtons at a 45 degrees angle. Thanks for watching, and next time don't forget to use a 45 degrees angle and the initial speed of 8.09 meters per second.